Now that we have seen in our previous video about trees, the general terminologies related to trees, now let's see into a major type of trees, which is binary tree, and the further types of binary trees. This is a very important topic of data structures from every examination point of view. So stay with me and follow the next video. Now that we have seen about the basics of a tree in my previous video, let's see what does we mean by a binary tree. Binary tree is a special type of tree where every node can have at most two child nodes. Every node can have at most two child nodes. It means that it can either have 0 children, means 0 child, 1 child, or 2 children nodes are permissible. More than 2 it is not permissible if you want to call the tree as a binary tree. Now just look at this example that I have drawn here. If you look at node A, it is having 2 child nodes. Which are the child nodes here? B and C. If you look at B, it is again having 2 child nodes, which are D and E. So I am just writing the number of child nodes there. If you look at C, it has 1 child node. It is also allowed. You can have either 2 or 1 or 0. Now if you look at D, how many children it has? It has 0 child nodes. Same for E and same for F also. So the given tree is a binary tree. Now let's see few more examples of binary tree. Tell me, is this a binary tree? A node with a single node, is this a binary tree? Yes, it is. Then let's consider this example. Is this a binary tree? Yes, it is a binary tree. A has 1 child node, B has 0 child nodes. It is a binary tree. Now let's see. Is this a binary tree? Yes. A has 2 child nodes, B has 0 child nodes, C has 1 child node and D has 0 child nodes. Okay. Now after we have seen about the general binary tree, let's look into another type of binary tree. So this one was the general binary tree. So this is the first type of binary tree, which is general binary tree. Okay, I hope it is clear. Now let's look at the second type of binary tree, which is a complete binary tree. Now in complete binary tree, the rules regarding the number of child nodes remain same. That is, every node can have either 0, 1 or 2 child nodes. But here there is an additional constraint regarding the filling of the child nodes. That is, it says that filling of any level must be done only from left to right. What does this say? See, I'll show you an example here. See, this we said that this is a binary tree. Correct? This is a binary tree? Yes, this is a binary tree. But is this a complete binary tree? No. Why? Because it says that filling of any level, and particularly you can say that the filling of the, see, I'll just change this, filling of last level. Filling of the last level of the tree must be done only from left to right. See here, the left sides are empty. These are empty. But the right child of C is filled, which is D. That's why this does not qualify as a complete binary tree. If we wanted to create a complete binary tree with the same nodes, then D must have been placed here. So in complete binary tree, the number of child nodes remains same as that we have seen in a binary tree, but the filling of the last level matters here. Okay. So let's take up another example. Is this a complete binary tree? Yes, this is a complete binary tree. Why? It has 0 children and this is the last level. So anyhow this is filled from left to right only. Is this a complete binary tree? Yes, this is a complete binary tree. Now, is this a complete binary tree? No, this is not a complete binary tree. Though it is a binary tree, but this is not a complete binary tree. Is this a complete binary tree? Yes, this qualifies both as a complete binary tree and as a binary tree here. Okay. Now, let's look at the another type of binary tree, which is a full or proper binary tree. It says that every node, must have either 0 or exactly 2 child nodes. So any node cannot have one child here. So it must either have 0 or 2. So let's look into the example here. Is this a full or proper binary tree? No, because A has one child node, which is B. So if we want to make this as a proper binary tree, then we must have either 2 children or no children. So A has 2 child nodes, B has 0 child nodes, C has 0 child nodes. Then say for example, I take this binary tree. Is it a full or proper binary tree? Yes. Why? Because A has 2 children, B and C. B has again 2 children, D and F. C has no child nodes. Now tell me, is this a proper binary tree? Yes, this is a proper binary tree. See, in proper binary tree, there is no compulsion regarding the direction of filling of nodes. So, the tree might be filled more on the right side also. If this would have been a complete binary tree, then D and E was only allowed at the left child of the tree, which is this. This is a complete binary tree as well as proper binary tree. But this one, this is a proper binary tree, but is this a complete binary tree? No. And why is it proper? See, in proper binary tree we are only concerned with the number of child nodes. We are not concerned with the direction of filling of any level. Okay. So here A has two children, B has 0 child, C has 2 children, D has 0 children, E has 0 children. So no problem, this is a proper binary tree. Now after this, the other type is a degenerate binary tree. In degenerate binary tree, every node has only one child. So every node has exactly one child node. So this is an example of degenerate binary tree. I'll show you another example of degenerate binary tree. This is also a degenerate binary tree. See, in this tree, every child is the right child of its parent node. So such type of a tree is known as right skewed tree. And in this particular example, every node is a left child of its parent node. So such type of tree is known as a left skewed tree. Other examples of degenerate binary tree can be like this also. Okay. So the compulsion says that it can have only and only one child, but it is not nowhere specified that whether it is to be the right child or the left child. Okay. See, there are many more types of binary trees, but I have covered these many types majorly because these are the most commonly used, and these trees hold application in other data structures also. That's why I have selected these 4 trees that I have explained in detail. Thank you.